In a recent article by the Pew Research Center, Why Many Parents and Teens Think It's Harder Being a Teen Today, stated among 69% of U.S. parents of teens ages 13 to 17 say being a teenager today is harder than it was 20 years ago. Suppose you randomly ask adults having teens ages 13 to 17 if they believe being a teenager today is harder than it was 20 years ago. Your results were 155 said yes and 85 said no. Use a significance level of 5% to test the claim of the article. Okay, so let's determine the null hypothesis. So the article stated that the percentage of adults who think it's harder for teens to grow up today is 69%. So we write that as 0.69, and that's the original claim. But the alternate hypothesis today, since we're testing, this article's claim, there's no indication of whether it increased or decreased. So we'll go with an alternate hypothesis of not equal to 0.69, and then alpha is equal to 0.05. Now, alpha is the probability of rejecting a true null hypothesis. And so when you set this alpha, you should consider the ramifications of making a type 1 error and also a type 2 error because they're somewhat intertwined. So let's take a look at the null hypothesis. All right, it says 69% of parents believe it's harder for teens today than 20 years ago. Okay, so then a type 1 error is rejecting a true null hypothesis. So that would be rejecting that 69% of parents believe it's harder for teens today than 20 years ago, although it's true. Okay, so what's a ramification of this? And there could be many. And here's one that I just pretty general, but came up with one. This could lead to disregarding the article's claim and doubting the research, even though it's correct. All right, type 2 error is not rejecting a false null hypothesis. And so in this context, it's failing to reject 69% of parents believe it's harder for teens today than 20 years ago when it's not true. Okay, so what kind of ramification can that be? Well, here's an example. This could lead to accepting the article's claim, which can misguide policies or discussions about why this may be true or not. Okay, and so once again, you consider ramifications when you set that alpha level of significance. All right, next step is to compute the significance level p hat. We see that in here was 240 U.S. adults, right? Or adults, excuse me. And R was the number, it was 155. In other words, 155 parents agreed that it's harder for teens today than it is 20 years ago. That is used to calculate p hat. So we would have 155 over 240. And so we have this equal to 155 over 240 minus RP, which is 0.69, divided by the square root of 0.69 times 0.31, divided by their sample size of 240. All right, so I already calculate this, but this gives me a negative 1.48. All right, so we know we're running a z-test for a proportion, and the sampling distribution we use is the standard normal distribution. So it's sketch the area or the p-value, but first let's go back up here and understand what type of test we're running. So the alternate hypothesis always determines that, and since we're using the not equal sign, this implies that we're going to be conducting a two-tailed test. All right, so then here's our sampling distribution, or the standard normal distribution, and negative 1.48 is about there. And it's a two-tailed test, so there's a corresponding value over here, the positive version, but the p-value is in both tails. And so this is half the p-value. And so to do this calculation, you definitely have to use something like technology. I used Excel here. You could use like a table or some other software. But the p-value can be found by going because we need to double the area to the left of negative 1.48, 2 times norm dot dis, and then my test statistic of negative 1.48. Sometimes you want to use more decimal places there so you can get better accuracy for the p-value. and then 0 and 1 for the mean and standard deviation of the standard normal distribution, and then 1 for true. All right, so I already computed that, but that gave us 0.1390. Okay, so now you use that value and compare it with alpha. So we see that the p-value is equal to 0.1390, and we can see this is greater than a significance level of 0.05. Okay, so what does that mean? That means we fail to reject or do not reject. Fail to reject H0. Okay, I mean the null hypothesis. So let's interpret this in the conclusion of the context of the problem. We might say something like the following. At alpha equal to 0.05 level of significance, there is not enough evidence to reject that 69% of all parents believe it's harder for teens today than 20 years ago. Okay, so you can also do this calculation in Excel, that Excel calculator that I gave you. And so let's go to Excel to do that. All right, so here we have, we know that we sampled or asked 100, what was it? How many was it? 240 adults. 155 of these adults agreed to the statement that it's harder for teens today than 20 years ago. The claim value from the article was 69%. And so we have that information, gives us our p hat. What parameter does the test involve? It involves a proportion p. And this was a two-tailed test, so it's not equal. And we still have the 0.05 there. If it's a different significance level, we would change that. We are using the normal distribution. It could have been the student t or normal, but it's normal. And we select the correct test statistic, which is the third one down here. And so we got a test statistic of a negative 1.48. If you round to 2 decimal places, it's a two-tailed test. And so is our test statistic positive or negative? Well, the test stat is negative, so it came out to be 0.1390 to 4 decimal places. And the conclusion is fail to reject H0 since the p-value is greater than alpha. Our data is not significant. Okay, that's it.